Welcome to the Deep Dive. We sift through the noise to bring you what matters. Today we're jumping into something that's, well, it's completely changed the game online. Large language models,
Yeah.
LLMs.
Yeah, it's really staggering. I mean, think about it. Text generation, translation, even helping tackle really complex
They're
problems.
just everywhere now, aren't they? The impact is kind of mind-blowing.
It really is. And how fast it all happened. But, beneath that surface, there's this fundamental tension, a real dilemma in the LLM world that our sources are digging into today.
Exactly. You got the closed source players, right?
Yeah.
The GPT-4s of the world. Often top performers, sure.
But there's a trade-off, a big one.
Yeah, limited reproducibility, access is restricted, and maybe most importantly, not much outside oversight. And then the other side, open source. Models like Llama, Mixtral, they're all about opening things up, collaboration.
And they're getting surprisingly good results, using some really clever techniques, not just brute force.
Which brings us to the core of this deep dive. We're unpacking a paper that makes a pretty bold claim, actually.
It argues that open source isn't just an alternative, it might be the most robust way forward. For research, for ethical deployment,
Yeah.
the whole package.
So our mission here is to really weigh these two approaches. We'll look at four things: innovation, actual performance, reproducibility, can others get the same results, and transparency. How much can we see inside?
Right.
And why does this matter to you listening? Look, this isn't just abstract tech talk.
No, not at all.
This is genuinely about the future of AI. Who gets to use it? Can we trust it? Who's actually steering the ship?
It's fundamental.
You know, if you think back, NLP started with these rigid, rule-based systems.
Yeah.
Clunky stuff.
Then probabilistic models came along, which was a step up.
But the massive leap, the thing that really unlocked today's LLMs, was that transformer architecture back in 2017.
Self-attention mechanisms, that was the key.
Yeah, that paved the way for the LLMs we're all interacting with, probably daily.
A huge shift. Which brings us neatly to, well, how does progress actually happen in these two different worlds? Where do the innovations come from?
Okay, let's get into that. Historically, you have to give credit to closed source, right?
Yeah.
They really pioneered some big ideas.
Absolutely. Like the concept of scaling laws.
Right, Kaplan and others showing that basically bigger models, more data, more compute power
Yeah.
generally equals better performance.
It was a foundational insight, but we're seeing now that just endlessly scaling up, well, it hits a wall. Diminishing returns.
So the game's changing.
Yeah, the focus for pretty much everyone now is shifting more towards, smarter training, things like curriculum learning, teaching models, step by step.
And RLHF, reinforcement learning from human feedback.
Exactly. Making the models more aligned and efficient without just throwing more hardware at them.
What about the architecture itself? I keep hearing about Mr. of Experts, MOE. Sounds complex.
It's a clever idea, actually. Instead of the whole massive model crunching every single input, you have specialized expert networks. And only the relevant experts get activated for a given task. Google's Switch Transformer is a well-known example, though the basic idea has been around for ages.
Interesting. And the closed source versions, they tend to use static routing for this.
Typically, yes. The path the data takes through the experts is kind of preset. Plus, you have models like GPT and Claude benefiting from massive proprietary data sets they were pre-trained on.
GPT-3 was a big moment there, right?
Yeah.
175 billion parameters. Really good at few-shot learning.
A milestone, definitely. But here's the critique, the downside of all this closed innovation.
The secrecy.
Exactly. It's opaque. You can't easily scrutinize it from the outside. It limits who can participate, who can build on it, and it kind of widens the gap between those who have access and those who don't. Globally, I mean.
Right. So how does open source tackle innovation differently then?
Well, their focus has really been on being adaptive, on efficiency, trying not to rely on just massive scale.
So working smarter, not just bigger.
Precisely. Look at models like Meta's Llama or Big Science's Bloom. They've shown you can get incredibly competitive, sometimes even more efficient, results without needing, nation-state levels of compute.
And they've made progress on that mixture of experts thing too, dynamic routing, you said.
Yes, this is a key difference. Models like Mistral AI's Mixtral 8x7b, it only uses 2 of its 8 experts for any given token.
Wow.
And others, like DeepSeek, Ulmo, they dynamically allocate the experts based on how complex the input is. It's much smarter about using resources, saves energy, boosts efficiency,
Right.
makes powerful AI feasible for more people.
That sounds like a huge advantage. What else is in the open source toolkit?
Well, lots of advancements in training, often using public datasets like Alpaca or DALL-E for fine-tuning. And then there's parameter-efficient tuning. LoRa is the big one there.
Low-rank adaptation. Explain that simply.
Okay, so instead of retraining a whole giant model for, say, medical text, LoRa lets you just tweak a small set of parameters, like adding a specialized adapter.
Ah, much cheaper and faster.
Massively. That's how you get things like clinical BERT or legal BERT without starting from scratch each time. It democratizes specialization.
Makes sense. And can smaller models learn from the big ones?
Yep, that's knowledge distillation. Think of a student model learning from a teacher. DistillBERT is a classic example, compressing the knowledge.
Okay. And retrieval augmented generation, RAG. That sounds important for accuracy.
Crucial. It basically lets the LLM look things up in an external knowledge base as it's generating an answer.
Like an open book exam.
Kind of, yeah. It helps ground the model in facts, reduces those weird hallucinations where it just makes stuff up. T5RAG showed how effective this can be.
So it's a whole suite of techniques focused on being smarter with resources. Any pure efficiency tricks?
Oh, yeah. Things like grouped query attention, GQA, in Llama it reduces memory use, and Flash attention reworks how attention's calculated, making it way faster and more energy efficient.
Lots of ingenuity there. So, pulling it all together, what does the paper conclude about innovation?
It basically argues that open source is winning on the how. It's not just about scale, it's about architectural smarts, efficiency, and letting everyone contribute. That approach, the paper suggests, is more sustainable and ultimately maybe more powerful in the long run.
Smarter, not just bigger. Okay. That's a compelling argument on the innovation front, but the proof is in the pudding, right?
Yeah.
How does all this actually translate to performance on benchmarks? How do they stack up?
Right, the scorecard. So performance gets measured in a few key ways. How good is the language? Can it reason? Can it adapt to specific areas? How efficient is it? And is it biased?
And we use standardized tests for this, like Human-Evil, MMLU.
Exactly. Human-Evil for code, GSM-8K for math problems, MMLU for broad knowledge, DRP for reading comprehension, GPQA for graduate-level questions. These give us a common ground for comparison.
And, okay, historically, closed-source models usually came out on top.
Generally, yes. They had the advantage of those huge private data sets, hundreds of terabytes sometimes, and very sophisticated optimization.
We hear about GPT-4's reasoning, Claude's focus on ethics, Gemini's multimodal abilities.
Right. Those are their strengths, often leveraging massive parameter counts and advanced techniques like chain-of-thought prompting.
But you mentioned earlier there are some doubts about those benchmark scores sometimes.
There are. The paper points to concerns about data contamination. Basically, parts of the test data might have accidentally ended up in the training data.
Ah, so they're acing the test because they already saw the answers.
Potentially, yeah. It can inflate the scores, and because the data sets and methods are secret, it's really hard for anyone outside to verify or replicate those results independently. You kind of have to take their word for it.
Right. So how are the open source models doing? Are they actually closing this performance gap?
They really are making remarkable progress,
Wow.
especially by leveraging efficiency and fine-tuning. LAM-A2, for instance, is known for high fluency and uses that GQA trick to save memory.
And didn't you say Mistral 7B actually beat GPT 3.5 on some tests?
It did. Despite being much smaller, it shows that smart architecture can really punch above its weight.
Any other standout examples from the open source side?
DeepSeek V3's MOE model is getting a lot of attention. By only activating needed experts, it's super efficient, but performs really well. We're talking high 80s, low 90s% on things like MMLU and DDrop. Impressive math and coding skills, too.
Our source material even includes a figure comparing models. Let me see. Okay. Yeah, it shows on MLAU, most top models are performing pretty closely now. The gap has really narrowed.
Exactly.
But it also highlights, let's see, Claude 3.5 Sonnet and this DeepSeek V3 are particularly strong on GSM-8K math problems.
Right, showing strengths in specific reasoning tasks.
Well, GPT-4 is consistently good across the board. And look, LAM-A 3.1 405B really stands out on DDrop reading comprehension.
It demonstrates how open source models are excelling in certain areas, likely due to those optimized, efficient designs and maybe specific fine-tuning.
And techniques like LoRa, which you mentioned, and something called CRLFT, conditioned reinforcement learning fine-tuning. They're key for specializing.
Absolutely. They allow open source models to be adapted very effectively. NVIDIA did this with their NVLM model, improved its math and coding using multimodal training without messing up its language skills. It could even handle handwritten code.
Still, open source faces hurdles, right?
Yeah.
Generally smaller data sets, less raw compute power.
For sure. Those are real challenges. Closed source still often leads in general broad NLP tasks because of those massive resources. But open source is catching up fast, especially in specific areas, through clever design and community effort. The potential for parity or even leadership is definitely there with continued investment and focus.
Okay, so performance is becoming much more competitive. That leads us to a really critical point. Reproducibility.
Right.
How can we trust these results if we can't recreate them? What does reproducibility even mean here?
Good question. In this context, it means, can another research group, using the same code, the same data, the same settings, get the same results? It's fundamental for scientific validity. If you can't reproduce it, can you really trust it?
And it sounds like this is a major roadblock for closed source models.
It is, almost by definition. Because they're proprietary, they don't release all the details, the exact settings, the specific tweaks to the training process, sometimes even the full architecture. OpenAI didn't release all the specifics for GPT-4, for example.
And things like RLHF make it even murkier.
Exactly. That human feedback process is complex and often tailored. Without knowing the exact feedback data and how it was applied, it's almost impossible for someone else to replicate the fine-tuning outcome accurately. It makes it hard to know if performance gains are real innovations or just artifacts of the secret sauce.
So verifying their claims is tough. Are there any cases where closed source shows some form of reproducibility?
Well, you could argue that models like Codex, behind GitHub Copilot, show a limited form. For a specific, well-defined coding task, it often produces predictable, consistent output.
But that's just for its specific application, not the underlying model itself.
Precisely. It doesn't tell you much about how the core model was built or trained.
Okay, so this seems like a clear win for open source then. Their whole philosophy is about sharing.
It really is baked into the ethos. Open source projects prioritize making the architecture, the training data, or pointers to it, and the methods public. This transparency is what enables reproducibility.
Got examples?
Sure, Meta's Llama models, especially Llama 2, have been widely replicated and built upon by universities and developers. And Hugging Face's Bloom is a fantastic case study.
How so?
It was developed completely in the open. The data set it used, called the Pile, is public. All the training logs, the settings, everything was shared. Thousands of researchers could then download it, run it, fine-tune it, verify the results.
Wow, so you can actually follow the recipe and bake the same cake, essentially.
Exactly. That transparency allowed people to adapt Bloom for different languages. It supports over 40 languages now and specific tasks, confirming its capabilities. Plus, initiatives like the Big Science Project and benchmark platforms like Helm push for standardized practices that make reproducibility easier across the board.
So the paper's conclusion here seems pretty straightforward.
Yeah, on reproducibility, open source models have a clear advantage due to that fundamental commitment to collaboration and transparency.
Which ties directly into our next criterion, transparency itself.
Yeah.
This feels like more than just reproducibility. It's about seeing inside the box and the ethics of it all.
Precisely. Transparency is about how accessible, how interpretable, how verifiable the model's inner workings are. It's not just a technical nice to have, it's arguably a moral imperative when these systems are making decisions that affect people's lives.
And closed source, again, inherently struggles here.
They do. They keep a lot under wraps, architecture details, data specifics, training methods. The justification is often protecting their intellectual property, security, or preventing misuse.
But that lack of disclosure has consequences, right?
Big ones. It means developers aren't necessarily required to spell out all the potential risks or biases. This is especially worrying in sensitive areas like healthcare or law, where a biased algorithm could do real harm.
Like that example with Google's Gemini.
Yes, exactly. When it generated outputs that seemed to reinforce harmful stereotypes, the lack of transparency made it really hard to pinpoint the cause. Was it biased training data, a flaw in the model's objectives? Something else.
You couldn't diagnose the problem without looking under the hood.
Right. And if stakeholders can't scrutinize these systems for bias, it erodes trust and makes accountability very difficult.
Okay, so open source champions transparency, full access.
Yeah.
But you hinted earlier, this has a downside too, a double-edged sword.
It absolutely does. The openness is fantastic for audits, for finding and fixing biases collaboratively, for democratizing research. It fosters a really healthy
Mhm.
ecosystem. But that same openness means the models can potentially be exploited more easily. Security vulnerabilities might be found and used maliciously. There are risks of misuse for generating disinformation or even censorship being baked in.
Censorship. Could you give an example of that risk?
Well, the paper mentions the case of DeepSeek's R1 model. Evaluations apparently found it deliberately avoided certain politically sensitive topics.
Like what?
Things like the Tiananmen Square protests or discussions around Taiwan's sovereignty were reportedly omitted or filtered. Now, we're just reporting what the source says here, but it raises serious concerns.
Yeah, that if a supposedly open model has hidden filters, that's worrying. It could reinforce certain narratives.
Exactly. It highlights the risk that transparency alone isn't enough. You also need to scrutinize what is being made transparent and whether there are hidden controls or biases, even in open systems. This particular example raises flags about potential state influence or ideological filtering.
So how do you get the benefits of openness while managing those risks?
It's tricky. The paper suggests things like tiered access to data, careful licensing agreements that outline responsible use, and perhaps decentralized governance structures, so control isn't concentrated. It's an ongoing challenge.
But despite those challenges, the paper still sees open source as having the edge on transparency overall.
Yes, because the foundational commitment is to openness, which at least allows these issues to be discovered and debated publicly, unlike in closed systems where they might remain hidden.
Okay, moving on from the technical and ethical frameworks. Let's talk about people, the community, collaboration. This feels like the soul of open source.
It really is. The contributions from this diverse mix, academics, independent developers, industry folks, even volunteers, they're absolutely vital. They drive everything from new features to finding bugs to ethical discussions.
And how does that compare to the closed source world? Can the community contribute there?
In a much more limited way. Participation is usually restricted to the edges, using their APIs, building plugins for something like ChatGPT, maybe using their specific fine-tuning frameworks.
So you can build on it, but not really change the core thing.
Exactly. Those interactions are external. You're not typically contributing to the fundamental model architecture or training process. Even security researchers or ethicists auditing these models often have limited ability to influence the core design due to that opacity.
It's like a walled garden versus an open field.
That's a good analogy. The closed approach offers stability and control, but it limits that spontaneous, collaborative innovation and deep scrutiny you see in open source. Open source is just a fundamentally different way of working, decentralized, modular, transparent.
Can you give some examples where this open collaboration really made a difference?
Oh, definitely. The Aya model is a fantastic example. It's a massively multilingual LLM supporting 101 languages.
Wow, 101.
Yeah, including many low-resource languages often ignored by commercial models.
Hmm.
That kind of inclusivity really only happens through broad global collaboration.
That's powerful.
Another area is adversarial testing. Open source communities are constantly stress testing models, finding vulnerabilities like ways to bypass hate speech filters, and then working together to fix them. That makes the models more robust.
And the sharing of knowledge itself is key, right? Platforms like Hugging Face.
Absolutely crucial. Hugging Face, GitHub,
Mm.
they're not just code repositories. They provide documentation, pre-trained models people can download and use, tutorials. It dramatically lowers the barrier to entry.
Makes cutting-edge AI accessible even if you don't have massive resources.
Exactly. It helps level the playing field, especially for researchers or developers in, say, the global south or smaller institutions.
But doesn't this openness lead to problems? Like people using the resources without giving back? The free rider issue.
That's a real challenge, yes. Open access means some will benefit without contributing, which can put a strain on the core teams maintaining these complex projects.
How do they deal with that?
Well, there are initiatives emerging. Things like AI Commons, which tries to create shared infrastructure agreements, and strategic partnerships linking up open source projects with universities, nonprofits, even industry partners who benefit, help provide resources and ensure sustainability. It's about building a resilient ecosystem.
Okay, this has been a really strong case laid out for open source across multiple dimensions.
Mm-hmm.
But let's bring in some balance. We need to look ahead, consider alternative views. This whole debate isn't settled, is it?
Not at all. It's very much ongoing, very dynamic. Despite all the arguments for open source, closed source models still have significant advantages that mean they're likely to stick around and remain dominant in many areas.
What are the main arguments for their continued strength?
resources, primarily. Access to enormous compute power and vast exclusive data sets gives them an edge, especially on those broad general benchmark tests.
And money, presumably.
And money. Significant, sustained financial investment that's hard for most open source projects to match. Plus, there's the risk mitigation angle.
How so?
For companies in high-stakes fields finance, healthcare, the controlled environment of a proprietary model can feel safer. They believe it offers better security, more stringent oversight, which is appealing for enterprise adoption.
Control, resources, perceived safety? Okay. But things are shifting, aren't they? You hear talk of hybrid models emerging.
Yes, that's definitely a trend to watch. As pressure mounts for more ethical AI and regulatory compliance, even closed-source developers are feeling the need to offer some transparency. This could lead to models that blend aspects of both worlds.
What might that look like?
It could mean companies releasing anonymized details about their training methods, or maybe high-level explanations of how the model makes decisions, or sharing curated data sets for third-party checks.
Or like the API access you mentioned.
Exactly. APIs allow controlled use of powerful proprietary models. Or a company might open source a specific tool or framework for fine-tuning while keeping the core model under wraps. It's about finding a middle ground.
Interesting. So, given these counterarguments and the rise of hybrids, where does the paper we're discussing ultimately land? Does its argument for open source still hold?
It does. The paper doubles down, essentially. It reaffirms that open source fosters transparency, reproducibility, and a more collaborative, equitable ecosystem. And importantly, it argues open models are proving they can compete, even lead, in terms of innovation and performance.
So the potential is huge.
Huge. But the paper is also clear that realizing this potential means confronting some major hurdles. It's not a guaranteed win for open source.
Okay, what are those critical concerns? What challenges does open source absolutely need to overcome?
Number one is probably financial sustainability. How do these projects compete long-term against corporations with deep pockets? They rely heavily on grants, donations, volunteer effort. We need better models, maybe federated compute networks, decentralized funding mechanisms.
Makes sense. What else?
Information integrity, that double-edged sword of openness again. How do you prevent misuse, disinformation, manipulation when the code is out there? It requires constant vigilance, robust testing, strong ethical guidelines, and maybe those decentralized governance ideas we talked about.
Right, the openness that's a strength is also a vulnerability.
Exactly. Then there's the challenge of actually dismantling the AI oligopoly. Can open source models truly match the scale, performance, and ease of use needed for widespread enterprise adoption? That requires continued breakthroughs in efficiency, parameter-efficient tuning, energy-saving training, all that stuff.
They need to be not just open, but also genuinely competitive alternatives in the real world.
Precisely. And finally, it all comes back to community. The pace of open source progress depends entirely on people contributing. Keeping that community engaged, diverse, and well-supported is absolutely fundamental.
So quite a journey we've taken. From the incredible rise of LLMs through this core tension between open and closed approaches, to a deep dive into why open source, despite its challenges, holds such immense promise.
It really does offer a path towards democratizing AI.
But, as we've heard, its long-term success isn't guaranteed. It hinges on tackling these serious financial governance and performance hurdles head-on.
Which leads to the final thought from the paper, which I think sums it up perfectly. It says the conversation needs to move beyond just open versus closed. Instead, we should focus on how open source LLMs can be designed to endure as sustainable, responsible, and robust models of the future of machine learning.
That's a powerful challenge. And it's something for all of us, for you listening, to think about. How does this evolving landscape shape the AI you encounter? What role do you want transparency and accessibility to play? Definitely food for thought. Thank you for joining us on this deep dive.